Hi, good morning everybody. Today we are going to discuss a very important topic called the Hunds rule of maximum multiplicity. In the previous class I told you off-bow principle, Pauli's exclusion principle and Hunds rule are the heart and soul of chemistry. तो आज अपन लोग डिस्कस करने जा रहे हैं हंस ऑफ मैक्सिमम मल्टीप्लिसिटी. हाउ टू राइट द डिटेल आउटर इलेक्ट्रॉनिक कॉन्फ़िगरेशन या हाउ टू राइट द डिटेल इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ एन एलिमेंट इन एटॉमिक ऑर्बिटल्स. दिस इज व्हाट वी आर डूइंग बाय द मीनिंग ऑफ हंस रूल. नाउ फॉर एग्जांपल, इफ आई एम टेकिंग हियर, say carbon atomic number, as you know, it is 6, and the electronic configuration is 1s2, 2s2, and you know s orbital means only one orbital is there, so we will make one box and my one atomic orbital. 2s also, s means only one orbital. And you know, p के अंदर how many orbitals are there? px, py, pz. They are mutually perpendicular. px, py, pz, they are at 90 degree. So this is our 2p divided into px, py and pz. तीनों बराबर एनर्जी का, they are of equal energy. That is why we say they are degenerate, they are equal. तीनों p orbital, only orientations are different. So 1s2 means there are two electrons. First electron will spin in the clockwise direction. The second electron should spin in which direction? Anti-clockwise. In an orbital, only two electrons can be maximum accommodated. Now 2s2 again, how many electrons are there? 2 electrons. So 1s2, 2s2. Now 2p2. In p there are 2 electrons. And अपने पास तीनों orbitals है, तीनों बराबर एनर्जी का. So 1 electron each. सब में एक इलेक्ट्रॉन अपन ने दी. First unpairing of the electrons. And if I am coming to say nitrogen 7, how many electrons here? 3. 2p3. So p में एक और इलेक्ट्रॉन आ जाएगा. p में maximum we can accommodate how many electrons? 6. Now how many electrons here? 3. So तीनों ऑर्बिटल के अंदर एक एक इलेक्ट्रॉन्स हो गया. So this is half filled electronic configuration. And half filled electronic configuration is symmetrical in arrangement. क्योंकि तीनों में इलेक्ट्रॉन्स हैं, तीनों में एनर्जी, तीनों इलेक्ट्रॉन में इक्वली बराबर डिस्ट्रीब्यूट होगा. So it is symmetrical and it is more stable according to Hunds. When degenerate atomic orbitals are available, each orbital should get 1 electron each according to Hunds. Is it clear to me? Okay. Now same thing if we are going to oxygen, say atomic number how much? 8. So 8 और इलेक्ट्रॉन बढ़ जाएगा. देखो ये हाफ फील्ड था किसमें? नाइट्रोजन के अंदर. नाउ वन मोर इलेक्ट्रॉन कम्स इन ऑक्सीजन हियर, isn't it? एक और इलेक्ट्रॉन अपन को अकोमोडेट करना पड़ेगा. देखो 2p1, 2p2, 2p3. Now the fourth electron will occupy anti-clockwise. Pairing will start only after each orbital get 1 electron each according to Hunds rule. The first statement of Hunds rule says that pairing up of electrons in degenerate atomic orbitals are only possible after each orbital gets one electron each. My dear children, suppose we are having, मान लो मेरे पास 4 chocolate and 3 of you are there, 3 students are in front of me, तो 4 chocolate कैसे मेरे को देना पड़ेगा? एक को थोड़ी देंगे मैं चारों, then it is an injustice from my part, then I am partial in my behavior. So मुझे क्या करना चाहिए? 4 टॉफी हैं, तो क्या करना चाहिए? तीनों को एक एक चॉकलेट दीजिए, तो तीनों खुश, तीनों को मिल गया एक एक चॉकलेट. And the fourth one, if I want to give to that fellow, the first one or second one or third one, it depends on me. But if I am the teacher, I will keep the fourth one with me only. क्योंकि सबको मैंने बराबर बांट चुके हैं, सब कुछ हो चुका है तीनों. That is Hunds. Now, if we are going to neon 10, देखो 2p में कितने इलेक्ट्रॉन्स आएगा? अभी तो देखिए कितना, 1 2 3 4 5 6 7 8 9 10. 2s2 2p6 and p is completely filled and it is more stable electronic configuration. That is why inert gases are more stable. They don't react because they are 2s2 2p6, ns2 nb6 electronic configuration is completely filled, and completely filled is more symmetrical than half filled, so it is more stable. Okay, now if we are going to say aluminium 30, after 2p which comes 3s, 3s के बाद कौन सा आएगा? 3p. तीनों बराबर एनर्जी का है, 3 प्री ऑर्बिटल्स. सो ये देखिए, इधर तक तो हाउ मेनी इलेक्ट्रॉन्स हो गया? 10. नाउ 11 12 पेयरिंग करना, देन 8 इलेक्ट्रॉन बचा. इट मे बी ऑक्यूपाइड लाइक दिस और इट मे बी ऑक्यूपाइड लाइक दिस, बट इट विल बी अनपिक्ड. फर्स्ट क्लॉकवाइज सोचना, पहले पॉजिटिव ऊपर की तरफ सोचना, फिर अपने नीचे की तरफ सोचना. If I am going to another element, another example. देखिए, manganese, atomic number 25. In Aufbau principle, I set the electronic configuration. In a hurry, we can write like this. Yeah. 2 and 5, how much? 25. So 3D में 5 boxes बनाएंगे. And S के अंदर how many boxes? Only 1. There are 5 d orbitals, and you know they are shape also. So they are degenerate. पांचों उनके लिए बराबर नहीं होता, लेकिन हियर ऑर्बिटल की बात हो रहा है. दे आर ऑफ इक्वल एनर्जी. सो 3d 5 में 1 2 3 4 5 पांचों कुछ, पांचों में बराबर इलेक्ट्रॉन्स था. सो दिस इज हाफ फिल्ड, more symmetrical and so more stable. For us to go electron over 3d 5, just like 2p3 or 3p3, half filled is more stable electronic configuration. If I am taking this example, manganese के ऊपर we are taking chromium 24. chromium 24 में 3d4 4s2 हो जाएगा, तो ये इलेक्ट्रॉन इधर कम हो जाएगा, isn't it? अगर chromium में एक इलेक्ट्रॉन और आ जाते हैं 3D के अंदर if one more electron comes to 3D, then 3D will become what? Half filled, and half filled is more stable. So in chromium, this exceptional configuration from forest 1 electron we will jump it into 3D5 to make it half filled. So chromium के अंदर we are having not this configuration, we are having the stable electronic configuration 3D5 forest 1. What is the reason? Being half filled, more symmetrical, more stable, according to which rule? Hunds rule of maximum multiplicity. A for example we are taking here. Sin 30, my dear children. Sin 30 means D10 completely filled हो जाएगा. देखो 18 plus 2 20 हो गया, 20 और 10 30 30 total electrons 30. Now 3D में how many boxes we make? 5 boxes we will make, and for us we will make 1 box. So ये हो गया for us, ये हो गया 3D. 3D 10 1 2 3 4 5 6 7 8 9 10 for us 2. It is completely filled. And completely filled is more symmetrical, so it is more stable according to Hunds rule. Is it clear? Now the same case if we are applying for copper 29, कितने इलेक्ट्रॉन होगा? 2 and 9 electrons are here. It is not completely filled. 3D 9 is not completely filled. So अपन क्या करेंगे? एक इलेक्ट्रॉन फॉरस से उड़ा के, इस अपन ने क्रोमियम में किया था, it we will fill it into this one. अब देखो 3D 10 force 1, 3D 10 is completely filled. All the 5 orbitals of 3D is completely filled and it is more stable. And you know, everybody wants to become stable. They want to get settled. Similarly, the orbital 3D 10 becomes completely filled and it is happy because it is more stable. This is some of the examples of which one? Hunds rule. So what is Hunds rule? In 2 ways I can define it. Pairing up of electrons. अगर इलेक्ट्रॉन को pair up करना, only after degenerate orbitals each one get 1 electron each. सब पे एक एक इलेक्ट्रॉन दीजिए, फिर पेयरिंग करिए, सब कुछ हो जाएगा. Then अगर half fill जैसे P3, D5, F7, it will be more stable. अगर कंप्लीटली फिल्ड हो जाता है P6, D10 या 14, अगर कंप्लीटली फिल्ड इलेक्ट्रॉनिक कॉन्फ़िगरेशन आ जाए, they are more stable than even half. So this is how we explain one of the most important principles of chemistry, atomic structure called Hunds rule. In the next class we will discuss regarding Hunds rule plus Pauli's exclusion principle. Have a nice day. Thank you, my dear.